Hello everyone, welcome to this Quintus webinar. My name is Sture Olsson. I'm the Business Development Manager for Sheet Metal Forming at Quintus Technologies. With me today I also have Dr. Björn Karlsson. Welcome.
Thank you, Sture. I work with customer applications, customer problems and our own research here at Quintus.
Today we'll talk about the Quintus high-pressure Flexform technology. We'll discuss the versatility of the technology and in particular the values to the low-volume vehicle industry. We will discuss the capability to cut and eliminate tool cost, and we will also look at how to reduce lead times. During the event we will also demonstrate a few examples and we will dive into details on three different components. The agenda for today will give you a brief introduction of Quintus Technologies, and then we'll give an overview of the Quintus Flexform process. And then we'll make a deeper dive into different applications, and we will have at least three examples that we'll present to you. We'll give you an equipment overview, and before we summarize we will also discuss the Quintus application support process. Quintus Technologies is a high-pressure company. To generate and to contain high pressure is the core of the company. For us, 2000 bar is high pressure, or 200 megapascal or 30,000 psi. When applying such pressure over a large forming area, it means a press force, or it turns out to be a press force up to 150,000 ton for our largest press sizes, to give you some perspective. We specialize in the design, the manufacturing, the installation and the support of high-pressure equipment all over the globe. We specialize in advanced material densification and in sheet metal forming. Let me give you an overview of the Quintus Flexform process. When operating with the Flexform process, we use only one rigid tool half, the other being a flexible rubber diaphragm, pushed down by the hydraulic pressure. We can work with different types of tools. We can work with cavity dies, and we can also work with block tools, and in both cases the flexible diaphragm push the blank into the die. We can form intricate shapes, we can form double curved surfaces, we can form undercuts, and we can even form and trim in one and the same forming operation. And last but not least, the technology can also be used for expansion forming. So all in all, the technology operates with one rigid tool half and the other being a flexible rubber diaphragm. The Quintus presses are used in many different market segments. In particular, the aerospace industry or airframe industry has used the technology for decades. You can find Quintus presses at more or less every airframe producer around the globe. It's very suitable because of the relatively low volume of production of airplanes, but with a big versatility of parts required in the industry. Today, we will however concentrate at low volume production requirements in the vehicle industry, in commercial vehicles, in the construction equipment, and also in the automotive prototyping arena. So typical market requirements in this segment would be a wide variety of shape and size. It would be high surface quality requirements, and it would also be, I would say, a big requirement for variety of thicknesses, ranging commercially from 0.5 millimeter up to 5 millimeter, and it would also be requirement for many different alloys in the industry, everything from aluminium to mild steel and also high strength material. And the Flexform advantages in this industry would be essentially the need for only one tool half, meaning that you can cut tool cost, and a tool cost saving in the order of 50% is very, very common, and even all the way up to 90% tool cost reduction can be made in relation to three-piece dies. Lead time reduction, again, minimum 50% lead time reduction, and we'll talk a little bit more about that today as well. Surface quality, because of the flexible rubber diaphragm, it's an opportunity to reach very, very high quality on the surface of the blank. And last but not least, you can operate with multiple tools in one and the same forming operation with this technology. The high pressure then, the high pressure advantage, we see less spring back, we see better forming repeatability when we use high pressure versus low pressure. And we also get a possibility to form a big variety of materials because of the high pressure. And also thicknesses, we can go all the way from thin foil up to, I would say, 10 millimeter steel material with close tolerances on the forming. Some customer references. Here we have a statement made by the Ford company, by Mr. Eric Rea, and he states that I have personally been involved in the fluid cell technology for over 20 years, and I have not found a better technology for the creation of sheet metal parts. The versatility, the speed, the cost, and the quality of the fluid cell press is unrivaled. Pretty strong statement by Ford. Another statement from a company in the Czech Republic, the Hoffman company, and it points a little bit more on the lead time reduction, where Mr. Hoffman himself states that lead time for form parts used to be months, but today it's more, the requirement is more weeks than months. And the high pressure FlexForm technology is ideal for prototyping phase. The last example I have today is from Scania and the Volvo Group in Sweden, where we see to the left, we see a need for production, and this is a particular truck carrier where they need have a special need for a special roof produced in a couple of hundred parts per year. The other example from Scania is a prototyping for trucks. So in both cases, for both production and in prototyping, the supplier of the parts has been the Swedish company Jobro. And I had the opportunity to interview Mr. Leif Norman at the Jobro company, and let's listen to what he says. Welcome, Mr. Leif Norman. Welcome to this meeting. May I ask you to first introduce yourself and your company to the viewers?
Yes, I'm Leif Norman, as you said, and I'm representing Jobro Sheet Metal Technology. And Jobro is a Swedish-based service provider, and we have two production plants, one located in Jönköping and the other one in Ulricehamn. Our business concept is to be the preferred partner for prototype and low volume production. And the fact that the Quintus concept always leads to the lowest possible tooling costs, that makes the technology the heart of our production concept. Yeah, the Quintus technology is superior when it comes to larger parts in smaller series. The larger the part is, or the smaller the series, the bigger benefits with the Quintus technology solution. Because if you have large parts, the tooling investments are extremely expensive in conventional methods. But it is a lot more cheap in the Quintus alternative. So large parts in extremely low volumes are very, very good in Quintus.
And for that volume, 10 to 15 pieces, then the Quintus technology is
absolutely superior. There is nothing else to compare with, or a lot cheaper.
So is cost, how about lead time?
Both the cost efficiency and the lead time are superior, and also the flexibility. When you are doing prototypes, you often come to a stage where you need to change something in the design. And in that case, the Quintus technology, based on just one tool half, is superior because it's quite cheap and very rapid to implement the changes.
Thank you very much, Mr. Leif Norman of the Jobro company. The next topic for today would be different applications. So I hand over to Björn Karlsson.
Thank you, Sture. I will talk today about a few applications which are suitable for flex forming. We have chosen 3 product groups to discuss: light structural parts, outer skin panels or visible parts, and finally heavy structural parts. And I will go through these application groups in some detail. We will now see how this looks in the real world. We have here a tray with tools, and the blanks are put on top of the tools, and then the diaphragm will come down and push the sheet material into the die. We can see that several different tool materials are used. The tools are placed quite freely in the tray, and now the tray goes into the press and the diaphragm will push down on the sheet and on the tools. So we move to the section with applications example, and I will start with light structural parts. This is quite a wide area. We can find such parts in very many applications in very many different types of industry. We have chosen here as an example the inside of a pickup truck, where you can actually see quite a few of those parts visible. We have the inner structure, we have the door reinforcement, we have beams and girders which are perhaps not visible, but all of them are suitable parts for flex forming. And not only light trucks, but pickup trucks, buses, utility vehicles of different types are areas where we find this kind of application. What is typical for them also is that very many times they come in quite low numbers and quite a few different models. As an example of this, we can look at the rear door in this case, where we can have windows, and where some purchasers don't want to have windows, and this of course requires 2 different tools and lower numbers of the produced part. And this means, since tool cost per part is important, this is one more advantage for flex forming. We can look now at an example. We have to show how suitable flex forming is for this kind of parts. We have made a demonstrator tool in our shop, which can be used for very many different materials and thicknesses. The tool itself is made of pre-hardened tool steel, Tulox 44, and it costs about 3,000 euros to produce. The measure of the tool is roughly 650 by 200 by 50 millimeters. And also what we can see in this example is how quick it can move. From the day we receive the drawing until we can show the first formed part can be within a week if we make sure that we do everything in sequence. This demonstrator tool has been used in very many different materials. It's not a part which exists in the real world. It's just something that shows that this can be done, and in very different materials and different thicknesses. It's not compensated for springback, which means when we try these different materials, we will have, of course, a varying degree of springback for each material. But it shows that the part can be formed, and it also shows that the material in question can be formed. And I have with me a few examples. This is a steel part, S355MC in 2.5 millimeter thickness. We have also used the tool to press high strength aluminum. 7075 in T6 temper. This is a very difficult temper to form. You can see also perhaps how the springback is quite significant, but we can form the material. And you may also see in the picture that we have still the plastic left on the blank. And this serves a twofold purpose. First, we protect, of course, the part from scratches when we leave the plastic on, but it also adds to the stability of the forming because we get some lubrication from this plastic. We have even tried titanium in this tool. Titanium is typically not found in light structural parts in those applications fields we have discussed. The main point is just to show that it works. We would like to show also that it can be simulated. It's not a difficult part to simulate, but we like simulations also from another point of view, and this is because we have difficulties seeing inside of the press what happens. And simulations actually for the first time gives us an understanding what happens to the material when it's inside the press and exposed to this very high pressure. So I would like to show here an animation of the forming of this beam. You can see that the blank is slightly bigger than the tool, and this is to get an extra stretch in the longitudinal direction of the beam. You see that the ends are bent down before the stiffeners are formed, and this gives us a little amount of extra stretch in the longitudinal direction of the part, which serves to reduce springback somewhat. And when the pressure increases more, we see that the central stiffeners are also formed. This simulation is made for 2.5 millimeter 355 material, which was shown here. And this is a moderate high strength steel, so we don't see so much springback after forming of this part. I would like now to move to another applications example, namely outer skin panel or visible parts. This is also an area where we in very many different segments of industry can find interesting applications, not only moving things like cars, buses, vehicles of different types, but also white goods, for instance, have a very high requirement for the surface quality. And this is one of the fields where flex forming is very suitable because of the flexible diaphragm. We don't have an upper tool. We form the part with the diaphragm, which comes down and makes sure that the forming is very gentle. We don't have the possibility of an upper tool which scratches the part. We find mainly those applications in external panels, of course, things that are visible, but also internal panels, and as I said, white goods are also quite often of interest. We have chosen an example here, which is an outer door panel for a convertible car. And in this case, of course, we need to have excellent surface quality. There can be no scratches on this part. It's also interesting that this application has typically very much fewer cars made than conventional cars with roof. So in this case, the tool cost is also of much bigger importance. We need to have a low cost of the tools per part, which is fulfilled with flex forming. And finally, it's interesting to have a high turnaround. It should not take a very long time to produce the number of parts and to move to the next project. In this case, this application, if the panel is made out of steel, we many times need a certain amount of stretch in the material. There's a process which is called bake hardening, when the part hardens a little bit during the painting operation. And for this to happen, we need to have a certain amount of stretch in the material. And this is no problem for us. Since the diaphragm comes down and stretches the material into the die, we automatically get this stretch, which means that bake hardening issues are typically not existing. We also get the additional advantage that the diaphragm stretch prevents oil canning. We don't have unrest in the material. Sometimes if a panel is only slightly formed, we can have unrest, so-called oil canning. But this is something that we can easily avoid, since the diaphragm will stretch the part into the tool. We can see an example of this in the next slide, where we have also shown an animation for you better to see what actually happens in the flex forming process. In this case, the forming is done in 2 steps. We start with a pre-forming, where not the full pressure is applied. We go down only so much, so we show that, or we see that the material is in contact with the whole part. And when this preforming step is done, we trim, and then the final forming step is made, where the flanges and all the sharp radii are formed. We can see this in the animation shown, where now the preforming happens. We see the material being stretched into the die, trimming, and then the final forming step, and then the final trimming. In this case, the intermediate trimming and the final trimming was not made in the press. We also typically see much less problems with wrinkling in flex forming compared to conventional sheet metal forming. And this is also due to the diaphragm, which is in contact with the sheet and keeps wrinkling pushed, or keeps the material pushed against the die so that wrinkles will not occur. So now we move to the final applications group, or applications examples, which is heavy structural parts. Maybe first we should say that there's no sharp distinction between heavy structural part and light structural parts. It's mainly where they are used and the thickness of the material, which is the distinction. The parts can look quite similar, but when you move up to maybe 5 millimeters or even above, we talk about heavy structural parts. So typically the border between the 2 applications is around 3 millimeters. Many such parts can be produced in a bending machine, but we also see a lot of applications where we have curved parts, or we have some features like hole expansion or other design features which are difficult to make in a bending machine. And then we see the great use of flex form machines, parts that cannot be produced in a simple bending machine. In the picture we see a few examples of such parts. As I said, there is no clear distinction between when a part is a light structural part and a heavy structural part. We, from experience, say that from about 3 millimeters and upwards, we talk about heavy structural parts. And this is parts which are also typically found in heavier equipment. It can be truck chassis, it can even be trains, forest machines. This is where we find such applications. Materials in this application field is most of the time steel, aluminum also to some extent, but not so many other materials are actually found. And strength-wise, we actually have applications which have gone up to very, very high strengths, up to 1500 megapascals. But in this case, maybe we shouldn't talk more about structural parts, because in this case it is more wear parts which are the application. But what's important to remember is we can work with such materials. There is no limit in strength or in thickness actually. We have also for this applications field, we have an example. We've made a tool to produce heavy structural beams. In this case, we have made beams in 5 millimeter S355 MC, which is a high strength steel. In this case, we could actually also use the tool with higher thicknesses. We have the inner surface, or the inner area of the part is what is determined by the tool, but we could use 4 millimeter or 5 or 6 millimeter in the same tool. This part is made in 2 steps. We need to use 2 forming operations to form this part. And you can also see in the picture that this part is not so easy to make in a bending machine because of the curvature of one of the flanges. So this is an application where we see advantages in using flex forming. We could make the part with straight edges. Now we have left the flanges, but we could use a blank which is slightly smaller so that we produce just a C-shaped beam. We could also put rivet holes in the blank before forming. We see in this kind of applications very often that people are afraid of fatigue, so such applications are very often bolted or riveted together. And there is no problem with flex forming to add those holes before forming, because we don't have the hydroforming lubricant or the hydroforming liquid in contact with the sheet, just the diaphragm. I want to show finally also in this case a simulation of this part where you can see how it is, or how it can be formed also without the flanges. And we just put in some holes to show also that it's possible to put the holes in before you start the forming operation. You can note also in this case that if we use a pre-cutting of the blank, we can arrive at almost 100% material effectiveness. There is very little extra machining necessary in this part, so we are close to 100% material effective for this kind of applications. So we move back now to the movie which we saw some time ago. In this case, I would like to stop and explain a little bit more of what we actually see. So we see now after forming, the tray moves out and the parts are formed. Here in the center of the picture is some kind of panel which is formed in a plastic tool actually, and please note also that the part is cut in the tool in the forming operation. Here is the light structural beam. It's just some aluminum material here. Here is the heavy truck part, which is made in 2 forming steps. All the others are made in just 1 forming step. Here's a panel, and note also here the choice of tool material, which is hardwood. So many times we can use such tool materials. Yes, and then we see finally a light structural beam. And then I give the word back to you, Sture.
Thank you very much, Björn. Very interesting. So let's go to the next topic then. I will then give you an overview of the Quintus equipment. So we manufacture two types of machines, you can say. One with a rectangular forming area, or a forming table, or tray, as we normally call it, and the other one being with a circular table. So to summarize, if we look at the type of machines or size of machines, we have a starting point at a forming area of 700 millimeter by next to close to 2 meter in length. And for such a machine, there will be a press force of 15,000 tons. So that's our starting point. And then we can stepwise go up in size from 700 meter in width to 1 meter all the way to nearly 2 meter in width, and lengthwise from 2 meter to 3 meter to 4 meter. And for the biggest machines, the press force by the high pressure is then up to 132,000 ton. So it's quite a lot. The width will also give you the depth or the tool height. So if you have a need for large parts in depth or high parts, then also the width is an important factor to bring into the equation. The Quintus support process. Let's give an overview of the support process. Quintus Technologies is really built on long-term partnership. As I've said a couple of times, the first machines were supplied back in the middle of the 60s, meaning that once we install a machine, that's a starting point of a very long partnership with our customers. Equipment, we have numerous of records of first when it comes to new product development and introduction to the market, and I would say that the company is very much driven by technology and engineering, technology development. Secondly, technical service is key to us. It's very important to have skilled service technicians locally available in the marketplace for us. But again, long-term commitments between the two parties is also of essence. And we offer today a strong service organization all over the globe. Last but not least, the application support, as we call it, our capability to talk the customer language, meaning that to be experts also on forming is of essence to us. We think you will find, we know you will find us as a good partner when it comes to forming, tool design. We discussed the forming simulation earlier today, so that's also important for us. But it's also important as a link back to our engineers, how to always continuously further develop equipment and to introduce new machine models that can do what you are requesting from the equipment. Forming simulation is a very important tool for us. We use it for evaluating the feasibility in projects. We support customers with forming simulation. We also use it in our tool design process. We've done numerous of tests with customers, show different opportunities with the technology. We work with different alloys, we work with different tool materials. And we also have an application center where we have the latest equipment available. We use it for tests and for training, and we'd also love to see you visit us when time allows, so we can prove our capacity. So to summarize, the Flexform technology, it's a cost-efficient process for low-volume production. It's excellent or ideal for low volume, where you have a high mix of different components, different parts. It can be light structural parts, as we discussed today, but it can also be skim panels, and it can be heavy structural parts. And the key benefit, really, we come back to that, is the low tooling cost. But also, perhaps as important today, is the ability to produce parts in a short period of time. So the lead time to develop new projects is a very strong point in this technology. So thank you very much for having joining us today. We would very much look forward to continue the discussion directly with yourself. And thank you very much, Björn, and thank you for joining us. And we now have time for some questions.